Now, after we know the rules of integration, the question is, how do we integrate? And as I mentioned before, you have to make sure that the function is ready, and ready means you get rid of radicals, powers in denominator, and you convert all the trigonometric identities. Now, after you do that, you may get one of four cases: either addition, subtraction, or composite, or you may have multiplication, division, or an integration that includes len. Now, I'm going to talk about the first case here: addition, subtraction, and composite. How would I integrate? Actually, you can integrate directly by rules, but under conditions. What are the conditions? First of all, to be able to integrate directly, what's inside the composite, the angle of trigonometric, or the power of exponential function should all be linear to be allowed to integrate directly by the rules. And you have to keep in mind that you should not forget to divide by the coefficient of x. Now, let's have an example and try to apply these things. Let's say that I have an integration of x cubed plus 5 plus e to the power of 2x, for example. Of course, depending on x. Now, how would I integrate this? I have to look at the function. Is it ready? Does it have radicals? No. Does it have power in the denominator? No. Does it have an identity? Also no, which means my function is ready. Now, it's addition between functions, so I can integrate immediately since integration can be distributed. So this will give you immediately x cubed will be x to the power of 4 over 4. 5 will be 5x. E to the power of 2x will be same, divided by the coefficient of x, and all of that plus c for sure. Well, this was the first example. Let's have another example. Let's say we have integration of x to the power of 5 plus fifth root of x plus 1 over x to the power of 5, all of these depending on x. Now, again, is the question ready? This should be your question anytime you see an integration. X to the power of 5 is ready. Fifth root of x is not ready, so I have to convert it to x to the power of 1 over 5. 1 over x to the power of 5 is not ready. I have a power in the denominator that can be taken up, so this is x to the power of negative 5. And all of these are ready now, so I can integrate directly by using the rules. This will give you x to the power of 6 over 6. This will give you x to the power of 1 over 5 plus 5 over 5, 6 over 5 over 6 over 5, x to the power of negative 5 plus 1, so negative 4 over negative 4, and all plus c. Of course, you need to simplify this. X to the power of 6 over 6 plus, when you multiply by 5 over 6, you will get 5. X to the power of 6 under fifth root all over 6 minus 1 over 4 multiplied by x to the power of 4 plus c. I think the idea is clear now. Another example on this. Let's say that we have integration of 1 over x plus secant squared 8x. Now, is this ready? Well, actually it is, even though we have 1 over x. Why is it ready? Because we have a direct rule for 1 over x, which is len absolute value of x. So this will give you len absolute value of x, and secant squared is not identity, it has also a direct rule. And if you forgot, you have to ask yourself, The derivative of what will give you secant squared, to remember the rule. It's actually tan 8x, and the angle is linear. That's why I can integrate immediately, divided by 8 plus c. Great. Okay. What about composite? I didn't mention composite here. So, integration of, let's say, 2x plus 3 all to the power of 7 dx. Again, is it ready? Yes, actually it is ready. What's inside the composite is linear, so I can integrate immediately. Now, watch this. Immediately means 2x plus 3 to the power of, you add 1 to the power, divide by the new power. And what did I say? Remember to divide by the coefficient of x. So if I want to divide all of this by 2, this means I'm multiplying by half, so immediately it will be 8 times 2. So you can take this out, so it will be 8 times 2, and of course plus c, which means 2x plus 3 to the power of 8 over 16 plus c. I guess the idea is clear. Let's give you a question to do, and your question would be integration of 2 over 3x minus 5 to the power of 9 depending on x. What's the answer of that?